Okay, given the following convergent series, we want to write this in summation notation. That's using a sigma. That's the symbol right here. So they gave us a clue. It's convergent. So we know its r is going to be, the absolute of its r is going to be less than or equal 1. So how do I find r? R equals our second term divided by our first term, or any term divided by the one before it. So I'm going to take 1/4 divided by 1. Any number divided by 1 is 1/4. So that's our r. For summation notation, I always start with I equals 1. We use the natural numbers for this case. And we go all the way to infinity. I have my r, and I need to know what exponent to raise it to. Well, if I just raise it to I, then my first term wouldn't be 1, right? Because 1/4 to the first power is 1/4. I'm going to be raising it to the 0 power first. So I'm going to have to write I minus 1. Because anything raised to the 0 power is 1. And as you can see here, I have 1/4 squared, that's 1/16. Now what if I want to find the sum of this infinite sequence? Well, series. That's an equation we're given. And we're given that the sum of an infinite sequence that's convergent is our a sub 1 divided by 1 minus r. So a sub 1 in this case is 1. So I have 1 minus 1/4. 1 minus 1/4, that's going to give me 3/4. So I have 1 divided by 3/4. Well, what do I do when I'm dividing fractions? I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. So the sum of this convergent series is 4/3. Next, I want to solve the following system of equations. There's two ways to do that. One is by substitution, and the other is by elimination. And you bet I'm going to go ahead and do both. So let's do substitution first. So in substitution, I need to solve either one of these equations for a single variable and plug it back in. So why don't I take 5x minus y equals 2, and I'm going to solve this for y. And I chose this equation because we already had y with a coefficient of 1. It's a negative 1, but at least then I'm probably not going to have to deal with any fractions. So I subtract 5x from both sides. I have negative y equals negative 5x plus 2. And then in order to get rid of this negative, I divide both sides by negative 1. That gives me y equals 5x minus 2. I'm now going to substitute this in to the equation I didn't just solve for. So I'm going to take 3x plus 2y, but now instead of y, I'm going to have 5x minus 2 equals 9. That's a bad equal sign there. Equals 9. So I have 3x plus 10x, because I have to distribute, minus 4 equals 9. I'm going to go ahead and add 4 to both sides. I get 13x equals 13. That means x equals 1. So now I've solved for x, but I'm not done. I need to plug this back in to either of my equations in order to solve for y. So I'm going to plug that in my first equation. I have 5x minus y equals 2. Now I'm going to substitute in 1. So I have 5 minus y equals 2. I subtract 5 from both sides. I get negative y equals negative 3. Divide both sides by negative 1. So I get y equals 3. So I just solved a system of equations. What does this tell me? Well, this tells me the point 1, 3 is where these 2 points would intersect. So if I had graphed both of these lines, this would be the point of intersection. Next, let's go ahead and do elimination. So elimination is when I multiply either of the equations by a constant so that their one set of coefficients, either on the x or the y, is additive inverses. And remember, additive inverses are numbers that add up to 0. So like negative 3 and 3 are an example of an additive inverse. So let's go ahead and take 3x plus 2y equals 9, and 5x minus y equals 2. So I'm going to go ahead and I'm going to multiply this second equation here by 2 on both sides. Because remember, what we do to one side of the equation, we have to do the other. And I'm doing this because then this negative y will become a negative 2y, and I'll have additive inverses. So that gives me 3x plus 2y equals 9. My first equation didn't change. My second equation becomes 10x minus 2y equals 4. Then what do? I add these together. 3x and 10x is 13x. 2y and negative 2y is 0y. And 9 and 4 is 13. I go ahead and solve for x. I can then plug that into either equation in order to solve for y. I'm going to go ahead and plug it into 3x plus 2y equals 9 because you didn't see me do that over here in this problem that we did first using substitution. And I'd like to show you that you're going to get the same answer regardless. So I have 3 times 1 plus 2 times y is 9. That gives me 3 plus 2y equals 9. I subtract 3 from both sides. I get 2y equals 6. I divide both sides by 2. I get y equals 3. So you can see no matter how we substituted, whether we use substitution or elimination, to solve this system of equations, we're going to get the same answer.